Welcome, everyone. You're here for the introduction to Kubeflow Pipelines. What we're going to do together today is build an application. It'll be a machine learning application that's built on Kubernetes. Everyone should have a Google Cloud account. Does everyone have a slip of paper in front of them with credentials? If you don't, please raise your hand. Okay. If you've never used the GCP platform before, it should be fairly easy to follow along, but if at any point you have questions, just raise your hand and one of our TAs will come help you out. So my name is Michal Casbon. I'm an engineer at Google on the Kubeflow team, and I've been there for about a year and a half. So to give you a sense of where I'm coming from, before I joined Google, I was head of data science at a startup in San Francisco. Before that, I was a data science engineer, and for about a decade before that, I was a data engineer in various enterprise companies. So that's my background. I'm coming from a sort of engineering, data engineering / data science background. And the people that I have with me today, we have a ton of Kubeflow expertise concentrated in this room. We have Abhishek. He's based in Sunnyvale. He's the engineering manager for the Kubeflow team. We have Dan Sanche. He's based in Seattle, another Kubeflow engineer. Jeremy Levy, he's one of the project co-founders there in the back and the tech lead. Dan Anghel, based in Paris, also an engineer, and Michal Zylinski, he's based in Poland. So if you have any questions along the way, feel free to ask one of them. So what is Kubeflow? What are we here to talk about? You've probably heard of it before. It's a framework for running machine learning frameworks on the Kubernetes framework. You get the idea. So more precisely, Kubeflow is a curated set of compatible tools and artifacts that lays a foundation for running production machine learning apps. It enables consistency across deployments by providing Kubernetes object templates that bring together disparate components. So a few housekeeping items before we get started. We're going to be talking about a few different layers. We have our infrastructure layer, that's GCP. We have our platform layer, that's Kubeflow, that runs on top of GCP. And then we have our application layer. And today we'll be building an app that can summarize GitHub issues. So on a few of the slides, I'll be talking about each one of those layers in the stack, and you'll be able to tell which one because it'll be highlighted up at the top corner. So Kubeflow is completely open source. It's on GitHub. Here's the link down here, just kubeflow/kubeflow. And it's not just the code that's open, but the community is open. We're open to new design directions. We're open to ideas. So if you'd like to get involved, there are a ton of ways to do that. We have weekly community meetings. Those are at different times, so depending on where you're located in the world, you can find a time to attend. You can interact directly on GitHub, creating issues and PRs. We have a Slack team and a mailing list. We have a dev summit that we're planning. We usually have those twice a year. We've had 2 of them already. So stay tuned. Towards the end of the year, we'll hopefully have something planned. But if you'd like to get involved, you're more than welcome to. OK, so this is an important link. If everyone could navigate there right now, this is the Kubeflow Pipelines GitHub Issue Summarization Lab. So if you find that link, it will give us a nice walkthrough. It'll give us all of the code that we need, all of the instructions, and some explanations for each step as we go along. Now, I'll walk through that up here so everyone can follow along, but if you have any questions, just raise your hand if you get stuck at any point. So what are we going to be doing? We'll start by setting up our environment, and then we'll create a brand new cluster from scratch, and we'll install all of the Kubeflow components on top of that. And then we'll move into the Kubeflow Pipelines dashboard, and we'll upload a pipeline, and we'll run it directly from there. And then we'll move into the notebook interface, and we'll run the same pipeline directly from a notebook. And then we'll end by cleaning up our cluster. OK. So it's going to ask us for a zone. Whenever you create your cluster, when we're setting everything up, the room's kind of divided unevenly. So what I want is for half of the room to use one region and half, or one zone, and the other half to use the other. So I'm going to say, so here's the line. If you're on this side of the line, I want you to use Europe West 1 Bravo. If you're on this side of the line, I want you to use Europe West 1 Delta. OK? That's going to be important because after we create our cluster, we're going to be using GPUs, and if we all try and hammer the same zone, we may run out of them. So everyone on this side, your Bravo, this side, your Delta. But those are the two zones that we're going to use. So write those down if you need to, but remember those because you're going to need to select that in a bit. All right, so let's get started. So I'm mostly going to talk through the introduction, so I'll skip this, but this is a publicly available link. You can go through this on your own. For all of those who are outside, I'm sorry there's not more capacity, but you can do this with your own account after the fact. We'll start by opening up the GCP console. If you haven't seen it before, this is what it looks like. So this is our main menu up here. And what's going to be most important for us is our project ID. We'll need that pretty much right away. But we'll start by opening up the Cloud Shell, which is this icon right up here. Is everyone following along? Does everyone have their account logged in? Oh, I should have mentioned this before. I recommend when logging into your account using an incognito window, because if you already have a GCP account, it can sometimes get confused. And we're covering all of the costs for this workshop, so you want to use the account that we gave you because we've set it up with enough quota for GPUs, and then you don't have to use your own credits. So I recommend using the account that we gave you. And an incognito window is the best way to ensure that there's no crossover. Okay. Can everyone see this screen? Cloud Shell? Okay. All right, so the other important thing for this, because we're summarizing GitHub issues, and that means that we're hammering the GitHub API. They have rate limits, especially for a bunch of requests coming from a single IP. So what we need to do very first is just to set a GitHub account token, and you can use any GitHub account, but you're essentially generating something with zero scope. So all this does is authenticate you as a user so that we're not sending anonymous requests, because otherwise we'll get throttled and things will break. Oh, I don't have the password for this account, which is fine. So when you generate this, it'll ask you the scope, and you just leave all the checkboxes blank and just generate a token. And paste that token into your Cloud Shell and save it as this variable, GitHub token. So no scope. This shouldn't have access to anything. It's read-only, and all it does is authenticate you as a non-anonymous user. Okay, so the other environment variables we're going to set are these. We want our deployment name, project ID, and zone. And your project ID is this right here. You just copy and paste that. And then zone is going to be Europe-West1-B Bravo and D Delta. I'm sorry, I can't hear you.
Is it possible to get more resources for the Cloud Shell? Because why is it opening? Is it a user setting that you can tweak?
Does someone want to go over? So I think what you're saying is that Cloud Shell isn't opening? That it's spinning, it's waiting? Okay. There is not anything I can do from here. However, is anyone else having trouble accessing Cloud Shell? Okay, let's give it a few minutes. Sometimes it can take a while to provision. Have things started connecting? Okay. Yeah, you're welcome to use your local terminal if you prefer that. If you're used to GCP, if you have the Gcloud SDK installed. You will need the Gcloud SDK, though. Okay, so we're setting a few more config settings. We're setting our project ID and our zone. And the next thing that we want to do is create a bucket. These two commands will create a storage bucket. That just gives us a place to put our files while we're training. Okay, our next step is to install the Kubeflow Pipelines Python SDK. Is this large enough? Can everyone see this? If you're having trouble, just let me know. Okay, so this is just a pip install command that installs all the Python dependencies that we need. This will allow us to compile our pipelines from Cloud Shell. Okay, and if you want, you can pin a couple of the useful dashboards. I generally do that just so that I don't have to search through this giant menu. But Kubernetes engine and storage are two of the most useful ones. Okay, how's everyone doing? Am I going too fast, too slow? Too fast, okay, I'll slow down. I'll give you some time to catch up. If you have specific questions, feel free to raise your hand and a TA will come to you. Wave at me if you have like a more general question about Kubeflow that you want me to answer while we're waiting. The zones, yes. So Europe West 1 Bravo is on this side, Delta is on this side. So who here has used GCP before? Okay, so that means it's new to about half the people. If you have GCP questions, it's okay to ask those. Who here has not used Kubernetes before? Okay, so it might get a little rough because I'm not going over any Kubernetes basics. If you get lost, you can ask questions. But I think the general expectation is that you understand what kubectl is. I will give you all the commands, though, so it should be okay. Okay, who would like me to wait a little bit longer? Or are you ready to continue? Okay, we'll wait a little bit longer. Okay, so our next step, there's going to be quite a bit of waiting time. So if it's okay with everyone, I'd like to go ahead and get the cluster created. It's okay if you're a little bit behind, because you'll have plenty of time to catch up. It's okay to do some of these setup steps after the next one. I can't hear you. What's your question?
I sign in, it signs in, nothing happens.
Are you in an incognito window?
I have to check that.
It might be interfering with your other Google account if you already have one. So yeah, I recommend using an incognito window with your lab account. Okay, so our next step is to create a cluster. And we'll do that using click to deploy, which is this UI right here. And what we need is our project. We can copy that from the Cloud Console. So we add a project ID, and we want to select setup endpoint later, because that takes even longer. It creates an external URL. We're not going to do that today. But we'll use our zone. Again, Bravo on this side, Delta on this side. And then we create our deployment. So we really just needed those 3 pieces of information: our project ID, set up our endpoint later, and your zone.
With the view jammer, do the same effect as deploying with the click.
Well, sorry?
The view jammer there.
Oh, the YAML file. Does the YAML file do the same thing? So if you view the YAML and then apply it to your cluster, I believe there's more going on. So it's using Deployment Manager. Jeremy, do you know if that's the same? I don't think that's a Deployment Manager YAML, is it?
Just metadata. Looks like metadata.
So the question is whether if you view the YAML, is that the same as clicking on Create Cluster?
Yeah, I think the YAML will be the same config, but you can't just apply it to your cluster. It's not a Kubernetes config. As Michal said, it's a deployment manager config.
Okay, so this will take about 5 to 10 minutes. So as Jeremy mentioned, it's Deployment Manager, which is a GCP tool that packages up everything you need. So it's not just Kubernetes YAMLs, but it's also enabling APIs and setting up service accounts. It's doing a lot more than just adding the Kubeflow components. So that's what's going on behind the scenes. And normally it would set up an external URL. We're not going to do that today because that takes an extra 10 minutes. It's doing a lot of networking, but there's a lot going on behind the scenes. And this is going to take a few minutes. So is everyone at this stage? Okay, a few hands. Raise your hand if you've gotten to this point. Okay. That's good progress. And if you're still on the setup part, you can do that at the same time as this. Okay. Oh, I wanted to show you what it looks like in the console. So Deployment Manager, that's what we were just referring to. And we'll be able to see a deployment here and a cluster here. So it's adding nodes, and eventually we'll see all of the Kubeflow objects show up here. So that's what's happening behind the scenes. Okay, so while we wait for that, let's talk about why we're doing this. Why does Kubeflow exist? So it came out of having faced a lot of the main challenges in building machine learning applications. One of the biggest challenges was moving from one environment to another. So forklifting code from local into dev, into test, and into production. That path can be fraught with error, and what we needed was something that gave us portability. So a way to package all those infrastructure components together so that we could forklift our code from one place to another without actually changing anything. Because there's a fundamental difference between running something locally on your laptop and running it in a data center in production. And another major challenge that we faced was the sheer complexity of machine learning applications. So the common perception is that when we think about our applications, we tend to think about the ML components as being sort of larger than everything else and more important. And that doesn't usually reflect reality. Reality is that there are a lot of other very important components as part of the application. And before you can even create your models, you need data. There's a lot involved in getting data, ingesting it, analyzing it, cleaning it up, exploring it, and separating out your training from your test set. So you can extract your features once you have your data, and then you can build your models. But once you have them, you still need to validate them. You want to be doing some auditing, versioning of them, hopefully doing some distributed training, and doing that continuously as new data comes in. Those models, they live somewhere. They live inside an application, and that means you have a user interface. That means you have some business logic. If you have users, you're doing some load balancing, and you need some serving infrastructure. That application has to live somewhere. It lives inside a platform. And for a platform, you need things like monitoring, logging, CI/CD solutions, auth, all of the normal things that go along with maintaining software. So that's a lot more than just ML. So we needed something that was more specific than just supporting the ML components of the application. So to solve the complexity problem, we needed something that gave us composability. So a way to create components that we could reuse, common things, common patterns and templates that we could reuse throughout our applications and create logical groups. And maintaining such a complex system is a challenge because it's not always straightforward to even identify errors. Some models, we don't even have good ways of identifying when there's things like bias that show up. So if we can identify errors, can we recover from them and prevent them from happening in the future? If we can fix those bugs, how quickly can we do that? How quickly can we go through the development process? In ML apps, that's traditionally been very difficult. Can we roll back to a version that didn't have the error? All of these challenges that are generally solved in the traditional software space are pretty big when it comes to ML apps. So composability helps us to shorten that development lifecycle so that we can iterate faster and fix things and automate that process. So capacity planning. A lot of times in machine learning applications, you may not necessarily have regular usage patterns. Training has a much bigger footprint in general than serving, and that can sometimes look different based on when new data arrives. But even when we have well-defined usage patterns, that can spike. We have users, demand can spike at times, and we want to be able to use our resources efficiently. So that's why we chose Kubernetes, because scalability is baked into the platform, it's fundamental to it. And then one of the GKE features that we really like is AutoProvisioning, which you'll see, it's part of the lab, so you'll get to see that in action later. Okay, so let's check on our cluster, let's see how it's doing. That looks good. And it looks like our Kubeflow components are still provisioning. All right, we can probably connect to it at this point. So we're still installing Kubeflow, but we can set up our kubectl so that we can see what's happening. So this pulls down our credentials. And let's see if we can connect to it. Let's see if it's ready. Okay, so we have a cluster. And this command right here, this sets up our context so that we're always looking at the Kubeflow namespace. So by default, everything is installed into the Kubeflow namespace. And we don't want to use the -n command every time.
So you have a choice. So if you go.
I tried to use email and username and password here.
Okay. So everything is slowly installing.
What you're doing is you're setting up how you want to configure it. And so if you want to use
We'll give that just a few more minutes before we run our next command.
Yeah, I tried to use username and password.
Okay, who else is at this point? Does everyone's setup look roughly equivalent to this? Raise your hand if you're following along approximately.
I tried an email, maybe it's not. Because I was putting
I can't hear you.
just using it was failing.
If Kubeflow is not running, we cannot do anything, you said, or should we do something else?
If Kubeflow is not running, we can't do anything? Do you mean for the next step?
Yeah,
So if your cluster is not up,
yeah.
you will need your cluster up for the next step, yes.
I thought so, but
Is it still installing?
yeah.
Okay.
So
We'll give it a few more minutes. So I remember before we had click to deploy, I remember having to do this manually, and it was a total pain. Like, you should appreciate how nice it is to just be able to sit back and let it do all the installing for you. You probably saw some of my early code that was like very involved and very complicated. So it's very nice to be able to just sort of wait until it's done. Did anyone have any questions about Kubeflow? Anything more general that I could answer? If it's something specific to your environment, let's get a TA over. Just raise your hand until someone comes. Any general Kubeflow questions? Or anything about pipelines? You have a lot of expertise in the room. Is that a question for me?
So I've heard Kubeflow pipelines as distinct from TFX pipelines, and that TFX can compile onto a Kubeflow pipeline. Are they distinct logical things, or?
Yeah, so the question is, what's the distinction between Kubeflow pipelines and TFX pipelines? So TFX pipelines, you're right, they can compile down into Kubeflow pipelines. But yeah, so they're two totally separate frameworks, like two totally separate projects. And TFX pipelines can run on either, I believe, what's the?
Apache Airflow also.
Airflow or what? Yeah, Airflow. So Kubeflow pipelines uses Argo under the hood, which is like a Kubernetes native version of Airflow. So two separate workflow engines. And TFX pipelines is basically one layer above that. So people I see who use that have non-Kubernetes clusters. And so they'll run Airflow over there, but they don't want to change their code, and so they want it to run in a Kubernetes cluster as well. Whereas Kubeflow pipelines is Kubernetes only.
Cool. Thank you.
Good question. Okay, any more general Kubeflow questions? If not, I will keep going. Is that what?
Do we have it on the private clusters or only on the Google Cloud?
Yeah, so the question is whether you can use Kubeflow on any Kubernetes cluster or only Google Cloud. Yeah, so it's on top of vanilla Kubernetes, so as long as you have a Kubernetes compliant cluster, you can use it.
And I can install it even without internet?
KFCTL is what you're going to want. KFCTL, it's a CLI tool. We'll go over it here, but it's essentially a command line version. Click to deploy is GCP only, but KFCTL is the command line version of this, and it lets you select your platform. And it gives you all the YAML. So that view YAML command, it essentially does that for you. Okay, who has a cluster up and available? That looks good. That's most people. Okay, so we'll go ahead with the next step. This is where it gets exciting. It's only one more setup step, and then we'll be able to actually use it. Okay, so this is where we set up node auto provisioning. This is exciting because it's a brand new GKE feature that I've been waiting for a very long time. It's still in beta. This is why we have to do it separately. It's not on by default. But we just run this command. And this will take 4 or 5 minutes. And what this is doing, if you haven't used auto-provisioning before, it will, based on the resource requests inside the cluster, it will automatically provision nodes for you. Well, this is important for us specifically because for our training job, we need GPU nodes and we need a lot of them. And you don't want to have GPU nodes just sort of up and running all the time. So we've added some code. There's a Kubeflow Pipelines command where we essentially just request RAM and GPUs. And that turns into Kubernetes YAML. It turns into a Kubernetes resource request, which auto-provisioning then recognizes, and it will give us a brand new GPU node with exactly as much as we need. And the cool thing about that is not just that we get it on demand, but that once that job is finished and there's no more demand for that resource, the node disappears and it gets decommissioned. So we're only paying for it for essentially as long as our job is running. So that's a cluster-wide setting, and that means that any resource request you send to the cluster will be, within the max CPU and memory limits that you give it. Within those limits, your cluster size will grow and shrink as a result. Okay, so that'll take a bit. Let's go over a few more slides. Okay. So let's talk about some of the main goals. So you heard about all the challenges. Those are just a few. There's many challenges. But the idea behind Kubeflow, if I could sum it up in a single sentence, would be to make it easy for everyone to develop, deploy, and manage portable, scalable ML everywhere. And that everyone is important. The idea is to make it more approachable and easier so that not just data engineers and ML engineers are the ones who can build applications. So our 3 main goals. We have portability. We want to be able to deploy across environments and forklift our code from develop into test into prod, and not just the ML components, but really the entire stack. We want to take our entire application and move it easily from one place to another. A second major goal is scalability. This answers your question about why we chose Kubernetes. Scalability is baked in, but we use vanilla Kubernetes APIs, and so the idea is that if you have a Kubernetes compliant system, you can run Kubeflow on top of it. But it's not just about scalability in terms of nodes. It makes your application a lot less complicated because, for example, networking, you can call services by their name without having to know where they're running. That's why we love Kubernetes. The third major goal is composability, is having this single unified tool. So common patterns that are specific to ML applications and not necessarily to anything else. We want to be able to reuse those components and pull them in pretty easily. So not just for the production version of it, but that full product lifecycle from design to development to deployment and then iterating over bug fixes and patches. And what's important for ML is to support specialized hardware like GPUs and TPUs. What we'll be using today is a bunch of GPUs to train our model. If you know what you're doing, this is how you can reduce costs and improve your model performance. So again, here's that GitHub link. It's for anyone involved in building a machine learning application, not just the data scientists or the engineers. And we're currently on the 0.5 release. We have quarterly releases, which means that you can expect to see 0.6 out in the summertime. And let's see, yeah, so it's Kubernetes native. Anywhere you have Kubernetes, you can run it. And it does this by providing custom resource definitions for things like distributed training. If you're familiar with Kubernetes patterns, you'll see very familiar ideas within Kubeflow, like this concept of microservices and declaring your infrastructure, managing your infrastructure declaratively. So the way we move things from one environment to another, we use a templating language. It started out with customize or with case on it, and we're now moving to customize. And these are essentially templating languages for Kubernetes. And we have support for multiple machine learning frameworks. TensorFlow and PyTorch have their own operators, but we support any Python machine learning framework. All right, so let's check on our auto provisioning to see if it completed. All right, that looks good. Okay. So we should have all of our components up and ready. That looks good. Whose auto-provisioning is complete? Okay. Is anyone just like very behind? Would anyone like me to slow down, or is this pace okay? If you want me to slow down, just raise your hand. Okay, we have a few people. Okay, so the next step that we're going to do is connect to our central dashboard. Oh, in the beginning, whenever we installed it, we decided we wanted to set up our endpoint later. That was a decision we made to save time because we don't need an external URL. We're just going to port forward into it. So if we run this command, we can port forward directly to the service. Ambassador is, it's a reverse HTTP proxy, and that means that we have a single entry point into our cluster. And from there, we can access all of the dashboards within Kubeflow and our own application as well. So we're going to want to run this command. And then this web preview button. This is what gives us port 8080. And here is our central dashboard. Okay, who's at this point? Who has their own central dashboard? Okay, we'll wait a little bit for everyone to catch up. So this is the main sort of single pane of glass for Kubeflow. So congratulations, you've just installed Kubeflow. What's the question?
Some of us don't have the service ambassador.
Don't have the service ambassador?
So basically, when I try to do the port forward, I get not found. I check my services. I don't know how to read it. So.
Open up the workloads. That doesn't look right. Let's get a TA over. Jeremy? I'm sorry?
If he sets up the context on the cloud shell, it will appear in the service because that hasn't changed.
So that's actually a good point. The command that we issued to set up the context will always send us to the Kubeflow namespace, and if you don't have that set, then it'll look like you have no services. And that wasn't the case for him. And you can tell because in Pantheon, if you click on workloads and services, it'll just give you a list. And so that's all namespaces.
On the cloud shell, in case the message that there were no services.
Yeah, so Cloud
Cloud
Shell and the Cloud Console, one's a UI, one's a CLI. But the UI should show you everything in every namespace unless you specifically filter it out.
Yeah, it looks like it didn't succeed when you actually deployed, or it's still the current deploy, probably having problems because of the one UI. Sorry,
for this part, the Python's web UI, right? I was trying to see where
I would.
or I'm not sure if I'm clicking in the wrong place.
I would retry.
Yeah, that doesn't look right. Maybe give it a minute or so. Maybe refresh that page.
This one.
That one. Or no, at the root. So go, yeah. Now try refreshing that. Sometimes it takes a few seconds. So what you can do, okay, so if anyone is having trouble accessing any of the dashboards, a good place to look is in Stackdriver logging. So let me show you what that looks like.
I would use a different name, but if you wanted to, you can go to the deployment manager.
So if you go into the console and scroll down to logging,
Yeah.
I recommend pinning this one too. It comes in handy. So you can filter by GKE cluster operations or container, and oftentimes that will show you a warning. So I don't know, in your case, you were having trouble opening up the pipeline dashboard, and so that looks like an ambassador routing issue. And so I would expect to see some ambassador errors in the logs. So that would be under GKE container. All of the logs are sent into Stackdriver automatically. That's part of GKE. So any errors should show up in here. And these are coming out of the pod logs. So you could also just view the logs for an individual pod. If you're having trouble with routing, that would likely be ambassador. Sure.
Service ambassador not found when they are after they enable autoscan, like there are two people. So they run the command to enable autoscan and they get when they do port forwarding, it says service ambassador.
Yeah, that might have been because the cluster wasn't finished setting up before they ran that command.
Just tell them to wait.
Yeah, just try it.
Oh, the cluster didn't finish to create before.
Maybe. So how would they add after the fact? So I'm not sure if waiting will work.
Destroy it and create.
I think so. Okay, who has their central dashboard up? Okay, that's not a whole lot. We'll wait a little bit longer. That's the next step. So if you're there, that's good.
I think what happened is the deployment manager had a bug and a lot of people's clusters did not finish deployment completely. So they got like 5 components ready and everything is stuck. So I'm asking them to redeploy Qflow. Okay. That's why I think some of them are not able to redirect to the pipelines page.
Fully deployed cluster?
Exactly. I think everybody ran the same. So deployment manager must have had
Okay, so they need to recreate the cluster.
So do you think that could have happened because of running auto-provisioning too soon?
running, sorry?
Auto-provisioning?
No, that should not cause it, in my opinion. But you're right. I mean, if it is another, they might have gone into a deadlock.
Yes.
You should find out for that, and that could be the only reason.
Okay.
So
How many?
Yeah, I was going to create a Qflow too.
I was going to have you continue with the command line tool.
I'm asking simply to just get rid of the previous.
That's fine. How many people?
All of that macro and a few people, so this
Okay. Okay, so we had a few people whose components did not deploy completely. If that's you, the recommendation is to delete the deployment. So let me show you how to do that. Unfortunately, it means redeploying. In Deployment Manager, this one checkbox, all you have to do is say delete, and then that will delete everything, but don't redeploy until that disappears. The question is where the new deployment is triggered. That's the click to deploy. So when you say create deployment, it'll create a new one of those. And then also, I recommend when you add auto-provisioning, waiting until your cluster is up and available. So like checking to make sure that you can get to the dashboard and then enabling auto-provisioning just to mitigate any deadlock. If it didn't deploy entirely, then yes.
It looks like
Show me your workloads.
here.
Oh yeah. Yeah, so it should be a much longer list. If you have that, then I recommend deleting the deployment and starting over.
Thank you.
Pretty sure it's the deadlock.
The deadlock?
I asked a bunch of people, they all ran the command with my
Okay. Yeah, so again, whenever you recreate your cluster, just make sure that you can access the central dashboard before you kick off auto-provisioning. Okay, so I'm gonna go ahead and move to the next step. Oh.
Control C. Yeah, Control C. Do you have that service? Is ambassador deployed on cluster? How do I do Kubernetes? Services. Yeah. This project or ambassador? It's running, right? And then we're trying to put forward 80.
So I think you need to do actually run the. Do you have kubectl installed on your local machine?
Local machine.
Try doing it from your local machine.
I have to. Well, I have OC, but
you'll have to get credentials.
Thanks.
Instructions say for. Okay. Running the same. What did the instructions say about port forwarding for Cloud Shell? I think they mentioned some.
yeah, no, I mean it's just simple. Should I? I mean, I'm assuming when I open this integrated ones, but I can do this one.
So go back to your shell. Yeah, go back to your shell. See.
What are the other commands I can
Can you go kubectl get deployed?
get deployed?
Yeah. Yeah. So I think, I'm not sure what you're doing. There are, but it doesn't look like you finished deploying. Yeah. Yeah. So I would
Just redo it. That's right.
Actually, did you, before you were looking at namespace Kubeflow, right? When you looked at the services.
Have you seen this before? This connection refused?
So try it.
Yeah, it didn't deploy yet. It didn't finish deploying.
And this is happening inside which script?
That's the ambassador pod.
Oh, the ambassador pod itself is, and in your cluster, all the services are there. Or?
To
It looks like it.
the service in order to do the deployment with the web app. So that's, I think, what the problem is.
I would, you can do deploy, you can do delete.
Yeah, I think look at services. I feel like
And then go to deployment manager.
scroll up.
So scroll down.
I didn't deploy. Maybe. Oh no, there it is.
Oh, yeah,
Scroll
there
down.
it is.
Let's see how many are there. This looks almost there except for, I think it's not complete. So there's only 20. There should be around 30. And pipelines UI, for example, and runtime is not there. So we'll have to start from scratch as well. I think the auto-provisioning has to be done maybe after the cluster is ready.
Okay.
We'll learn.
I have another one.
And then what I would suggest is actually deploy the command line. So if you go to www.kubeflow.org. No, www.kubeflow.org.
All right, so it looks like I ran into the same error. So lesson learned, don't run auto-provisioning too soon.
Kubeflow.org.
Good thing I have this backup right here.
No, .org. Go to documentation. Getting started. Google Cloud for Kubeflow. And then go to documentation. Deploying Kubeflow. Deploying with the CLI.
That's not what I wanted.
And so here are those instructions you can go through. You can skip to, you've already done the project setup, so shouldn't actually scroll up. Just go to step 2, where you set the password. And so you're going to want to use basic auth, so just pick a username and password that you want to use to log in.
Why isn't it giving me my tabs? I'm trying to make this larger. Okay, so this is a cluster where I already have things running.
Can you go to Kubernetes engine, so let me see what your dashboard says. I want to see clusters.
Okay, so if you can access the pipelines dashboard, who can access the pipelines dashboard? You are the most patient people in the room. Well done.
Do kubectl config. Yeah, cluster info. Or maybe it's just
So the problem was that running auto-provisioning on the cluster essentially caused the deployment of the other services to fail. So if those were not completely installed and auto-provisioning was run, then it effectively shut down communications to the cluster. That's right. Yeah, so that happened to me as well.
container cluster space.
Okay.
Space clusters. List. You spelled it correctly.
Okay, so we'll keep going, and what we're going to do now is we'll compile a pipeline. So this is that pip3 command that we ran before. We're downloading a Python file. That's this GHSum file. And inside here is a pipeline description. And we'll look at this in a bit more detail in a minute. But for now, we're just going to run it to generate our pipeline command. This is a compiled Argo code, so that when we upload this into the pipeline's dashboard, it will actually run on top of Argo. So what we have after we compile it is this tar file. And we'll go into our pipeline's dashboard, which is here, and we'll upload it
So now,
by URL.
15-1. So
We'll give it a
what you
name.
need is do G-Cloud container clusters get credentials and change it to Kubeflow 2, because you're currently pointing at
Oh,
Kubeflow as your current cluster.
let's try that again. I don't know what's going on here. Do you have this? You don't have 4500, do you? That was not supposed to be in the papers that got passed out.
Kubeflow is still pointing at your Kubeflow cluster. You want to
All right.
your Kubeflow 2 cluster.
That explains why the cluster is called Kubeflow 2 and why it just appeared.
And so you have to go back up to get credentials. Yes.
Do you have a cluster up and running?
And change deployment name to Kubeflow 2. Okay, so type kubectl config.
All right.
Exercise in patience.
I hope someone else doesn't have that. Does anyone have DevStar 4505? How did I took them out?
I don't know if he's asking for a question.
Raise your hand if you have 4505. That was a yes? You have 4505?
You run kubectl get deployed.
Let me grab one out of the envelope. There's no more left. We had so many extras.
Get dash n. Qwiklab. So you want to specify the namespace for Qwiklab. Okay, so now it looks like everything deployed.
But I think you can still try logging in and see if it's I'm not sure.
Yeah,
Thank
if
you.
want to enable GPU to do provisioning.
That's all right.
That's all right.
But those aren't gonna be set up.
You go to the
They're not gonna have
port
clusters on
command.
them. Do you have a cluster already set up? You have a cluster already set up?
No, I just deleted it because I get
Oh, okay. Yeah, that's right.
pipeline, no pipeline.
That's okay. Thank you though.
So you need to start from scratch.
You have to add
That
the
takes a while.
You might want to log into this just to see like if that is there or not.
Well, someone's using it.
So you don't need this.
No, thank you though.
And which gets
Video?
redeploy.
Redeploy? Okay. With one of these. Does anyone have 4510? All right. I'm gonna use that one.
I think your configuration should be stored in your home directory. I don't know if it uses the same share home directory with CloudTrol. If you can run kubectl cluster info or kubectl current context to see. Okay. Yeah.
Sorry, I can't read this from here.
Oh, it doesn't have a project.
Okay. Yeah. So I delete them. And then
I can delete them.
yeah, you can also start off with different names so you don't have to wait. Yep. Yep.
Then we get
All right, so it's going to take me a few minutes to get a cluster up and running. So raise your hand if you have a pipelines dashboard? Okay, that's a few of you. I apologize to the rest of you that had to restart from scratch.
Show them the Kubernetes engine page as to how it looks once it's deploying. So you get a sense of like what to look for.
What do you mean?
If we go to the Kubernetes engine page on the console,
the ambassador is in this name.
Can you do kubectl get deploy?
that'll give them a sense of like what to look for once the cluster starts showing up. Still creating.
Yeah, it's still. Okay.
I mean, it doesn't look like everything got deployed.
Okay, well, I'll talk you through running a pipeline.
I'm not sure why.
Okay, so we looked at using Python, using our KFP SDK to generate our tar archive. That's Argo definition. So when we upload it, we see this nice pipeline. I wonder if I still have it up. Oh, there we go. Okay, it'll look similar to this, where you have a train and a serve step. And that's everything inside that pipeline definition. It just defines what the steps are, which container to run at each of those steps.
Having a proxy issue with.
So once we've generated that tar, uploaded it, that's where we want to run it. That looks like this. We create an experiment. For an experiment, you can have any number of runs so that you can compare between execution of pipelines. You can see what config parameters you used and what the results were. These are the parameters that you're going to need to give your pipeline. Your project name, the GitHub token that you generated in the beginning, and then the name of your bucket. So you add those here, you give it a run name. You can have any number of runs within an experiment.
Can you do KubeClub? Can you look at your cluster?
And you click start.
Deploy? I mean, get deploy. See what
So clicking on start is
get deploy.
when you execute that pipeline. One of the commands inside that workflow definition is to request resources. Now this particular pipeline is running, you're training a model, you're serving it, and then you're standing up a web app. And so in the train portion, we're requesting GPUs specifically. We're requesting 4 GPUs and I think like 48 gigs of RAM. So we're requesting a lot of resources. And with click to deploy, we're just getting a default cluster with essentially the minimum amount of resources necessary, and that's 2 nodes. That's 2 pretty standard nodes. I think it's N1 with 8 cores, so N1 standard 8. You have 2 of those, and that basically just covers all the services you need to run Kubeflow itself. So when we kick off that training pipeline, and we request all those resources that don't exist, that's where AutoProvisioning kicks in and gives us a GPU node with enough to cover the resource requests that we've put out there. As long as it's underneath that max, which we defined when we turned on auto-provisioning, it should give us enough. So this message right here, it'll tell us that our pipeline is in pending state because it's unschedulable. We don't have resources. But what's happening behind the scenes is that a node will automatically be added to the cluster, and as soon as that's ready, then this message will disappear. That takes about 3 to 5 minutes. And then you'll get into the container creating part where it pulls the image, it has a node that it can run on, so it starts pulling the image, and then it starts executing. So that training step looks like this. You'll see it run through, it can access the GPU. So the first thing it does is it downloads the data files, it uses a checkpoint. This is actually a pretty big model, and it would take way too long to train it in just one setting. So we're pulling from a checkpoint and then running this for about 15 minutes using 4 GPUs. And then once that's done, oh, I did promise you that I would show you what that Python file looked like. So this is that file that we compiled in Cloud Shell and then uploaded into our pipelines dashboard. And it uses the Kubeflow Pipelines SDK, so it pulls in those libraries, and it defines these different steps. So you have, these are the arguments, and it defines a training step. It gives it a name, defines a container to use, and then the command to send in, and a serving step. And we want serving to run after training. And this is where we're requesting those GPUs. We're requesting 4 GPUs. And this is the request that triggers auto-provisioning. So auto-provisioning is just a GKE feature, but we're using the Python SDK to request those resources. And that will turn into the familiar YAML resource requests that you're familiar with. And then web app is our final one. So this is the application that uses our trained model that we're serving to send in the text of a GitHub issue and receive a prediction for what the title of that GitHub issue should be.
Yeah, no, I think what's happening is it's just taking a very long time to wipe out.
So one artifact of training, if you go through the training process, and you click on the details, you can actually see an artifact show up, and that's TensorBoard. And if you've ever used TensorBoard before, this workshop doesn't cover it, but there's a ton of detail in here. You get a lot of graphs on the type of statistics that were generated during the training process, so you can find out information about your model, how accurate it is for whatever it is you care about, and you get just a ton of information in there. Now this is the web app. So the cool thing about Ambassador, when it's working, when we install it correctly, is that we can just add a term to our external URL. So because we were port forwarding in, we had a URL that looked pretty much like this for our central dashboard, and then just adding web app with the trailing slash sends us to the application that we deployed, and that's this one. So if this were live, we would click on populate random issue. That would give us just some random GitHub issue. It would populate this box, and then generating title would bring up a prediction. So what's happening behind the scenes is that web app is in its own pod running on our cluster. And one of our steps was to serve the model that we just trained. And so we have a serving pod, and that web app is calling just as a REST call to our serving pod and receiving a prediction from it. And then that would show up right here.
No, I think you want to use the cloud show because you want to execute the commands from inside the cloud.
So for anyone who is able to run the pipeline, has anyone actually seen it run? Okay, a few people. Were you able to watch auto-provisioning kick in and see the cluster count, the node count inside your cluster go up? That's one of the coolest parts. I'm sorry I wasn't able to show that live. Looks like my cluster is still provisioning. so our next step is to run a pipeline not just from the pipelines dashboard, but from a notebook. That wasn't a question, was it? Okay. All right, so from the central dashboard, if you click on the notebooks dashboard, that will bring you to this screen right here. And you can spawn a new Jupyter Hub instance by clicking here. You can leave all the defaults, just give it a name. And what that does is it creates a brand new pod on your cluster, and that gives you your own Jupyter Hub environment. So it'll take a few minutes to pull down the image. We're just using the stock TensorFlow, I think, 1.13 image.
Getting started. Google Cloud for Kubeflow.
Yeah, so the default is TensorFlow 1.13 for CPUs. Is there a question?
So do you have administrator permissions, and administrators are able to create new notebook servers and can say that this user should use this server, or how does it work?
The question is about having administrator privileges for specifically the notebooks. So I have that, actually it's on a later slide. That's something that we're working towards in the 1.0 release, is multi-user. So some of the components support it, some of it don't. Are you asking specifically about notebooks or Kubeflow in general?
Well, if it's Kubeflow internally, I guess it's also then available in notebooks, right? Or not?
Is what available?
Multi-tenancy, role management, things like that. Multi-using.
I mean, the way Kubeflow components are developed is pretty independently, so not necessarily. If it's available in one component, it's not necessarily available in another. I mean, it's your typical open source project. So I'm not exactly sure what capabilities exist specifically in notebooks, but I do know that that we're working towards a more consistent approach to it, so it will eventually get to that point. Yes, there are several people. The question was, are there people running Kubeflow in production? Yes.
Which company?
Abhishek? Can you talk about any companies that are running Kubeflow in production? Yeah, I'm not sure we're able to name names for too many of them.
I know that there are a few companies that are using Kubeflow for on-premises inferencing using GPUs. In retail industry, there are a few companies in financial industry which are again doing on-premise deployments of models.
So inference in production with GPUs in the retail space.
Retail and FinServ.
And FinServ. Mm-hmm. Any more questions?
More than ZCP volume and file system, other volume, NFS, storage OS or others, there's a support only for these two now. I'm using Kubeflow on my own. I have a cluster at home.
On-premise cluster.
On-premise, yes, and there's no way about to use other file system. GCP and file system.
No, you should be able to use something like NFS volume if you have an NFS server.
Yes, but in the combo, when you choose, there's only way to select
Is this, so the question is about file systems specifically from notebooks?
Yes.
And are you able to use anything besides, so there's persistent volumes?
From notebooks, if you take your NFS volume and create a persistence volume with it, then you should be able to attach it to your Jupyter notebook.
So the response was, if you create a persistent volume from your NFS mount, you should be able to attach it to the notebook.
Appear in the...
It will appear.
Okay, persistent volume.
Yep.
Sorry. Any other questions?
Just one more question, but about the persistent volumes before pipelines. Well, actually, a few weeks ago, when we were deployed the Kubeflow on-premise, in our on-premise cluster, we didn't find any information on pipeline volumes. So, I mean, some kind of way to declare that you have volumes and that you actually don't want to transfer the data to cloud back and forth, paying the dime for each request. And, well, we just didn't find any way to actually keep the data locally. And the same cluster. Is there any way to do it? I've seen the related GitHub issues some time ago, but I don't know if it was if there was a pull request or. So the question is it possible now?
So for an on-prem cluster, within pipelines, is it possible to define a persistent volume locally that doesn't go to the cloud? I would think so.
I think if your components, like your stages, are doing some computation, they should definitely be able to use your local volumes as long as they are mounted as.
Yeah, as long as they can access them.
But I mean, I'm talking about an easy declarative way to use it in the DSL itself.
There is a new change from Aricto folks that was recently merged into create a new DSL component which says like you can attach volumes, you can specify the volumes in each of the pipeline stages. And this is very recent, but
adding GPUs, it might be a quota issue.
Go to the Aricto booth in the expo
with pipelines, it's happening.
Showcase center, and they are around. And we can explain
I actually have had a talk with them. Yeah, but it's well, actually they're proposing a paid solution. But the thing is that
actually your solution doesn't require paid.
Issues provisioning GPUs
they have made a DSL change in pipeline DSL to attach volumes, and that should not be. Their volumes are paid.
You could try changing the pipeline to use GPUs that's possible, and then it can
I've definitely seen a GitHub issue regarding this exact problem.
Yeah, so I think monitoring the GitHub issue is probably your best bet, and like comment on it because the more activity we see on it, the better. So we think there's a new feature that's part of pipelines, but talking to the folks at Aricto, they have a booth here. That's probably your best bet. If not, follow up on GitHub because it is a good feature. Is this a question for a TA or for me? Okay. Sure.
The question for you is the data is copied into the runtime process or not?
I'm sorry?
Is the data streamed or copied?
Is the data streamed or copied? Streamed. So it's copied from a bucket. Copied into the bucket that you created in the beginning.
Yeah, but it's copied to the process where the training does. To the volume attached to the training.
It's being copied from one bucket to another within the cloud, within GCS. So the command's coming from the training step that you created, but the data is moving from one GCS bucket to another. So just within the GCP network.
You could have issue summarization.
Okay, so does anyone have access to their Jupyter Hub instance? Has anyone gotten that far? All right, you're soldiering on, I'm proud of you. All right, so after you spawn your instance, you should be able to connect, and it'll look just like any other Jupyter Hub instance, just like this. And if you open up a terminal, the first thing you want to do is install the latest version of Kubeflow Pipelines. And this is important because even though it ships with the distribution of Kubeflow, components are developed independently among different external groups. And so the pipelines, they actually release much more quickly. Core Kubeflow is every 3 months, so once per quarter, but Kubeflow Pipelines is much more frequent. So you always want to install certain components to get the latest. So if you download the notebook, I might be able to show you. Here we go. This is what it looks like.
Did you specify the RAM and the GPU? Or?
So here's the notebook with what we're doing here, and what's interesting about this is that instead of having a Python file that we compile locally and then upload, we can actually just run it from within our notebook. And using the Pipelines SDK, we can create experiments and run them directly from our notebook. So what we do here is instead of just our train, serve, and web app steps, we're adding a new one. And then we can actually run it from within here. So all of this is on GitHub. You can look at this on your own. But this is the important command down here. So we're compiling it within our notebook.
Yeah, so that was that, but then
and then running it right here. And this gives us a link to our running pipeline.
Scroll down.
And it looks like this. So this is how we can modify something that we've already created without having to leave our notebook environment. So you can go back and forth without having to worry about compiling things locally and transferring files.
Okay.
Okay, we are running a little bit low on time. I have a few more slides, but before I go into those, they're mostly just on future steps for pipeline, like roadmap. Are there any other questions before we do that? All right, I'll go into our last few slides. Okay, so I just wanted to describe some of the default components within Kubeflow. So click to deploy gives you a default install, and this is not a complete set of components, but it is what you get by default. There's a lot more that you can add on top. But we have our ingress components, and there's a lot behind this. I'm just going to lump that into components that give you a single entry point into your cluster that handles all the auth for you so that you don't have to do it in anything else running inside your cluster. From there, you have the central dashboard that we saw. You have your pipelines dashboard, notebooks, TF job for monitoring your TensorFlow jobs, TensorBoard, Katib, which is hyperparameter tuning. So whenever you're running a training job, you can see nice statistics, lots of pretty graphs. If anyone read the Vizier paper from a few years ago, this is the open source implementation of that. And then Argo is this is what powers pipelines. It's the workflow engine. Each of those UIs has an operator behind it. So you have one for TensorFlow, for TF jobs, one for PyTorch. And then you also have Argo and Katib operators. And then on the serving side, you have one for serving trained TensorFlow models and Seldon for packaging up any Python library. So what's new in this current release? So KFCTL, the person who asked me the question about installing on-prem, this binary is what you want. So it used to be just like a shell script, and it's now a fully fledged Go binary. So there's lots of bug fixes in the new version. But that separates out creation of the platform from installation of Kubeflow. Click to deploy did all of that together. But if you already have a platform, if you already have a Kubernetes instance, you can use KFCTL to just put Kubeflow on top of it. There's a new, so we just skipped all of the endpoints, but there's in-cluster auth, so that you don't have to use an OAuth token. There are some things related to ingress that have changed. And Istio was added, which will eventually replace Ambassador. I think we're working on that for our next release. The central dashboard, you got to see the nice pretty version of it. Too bad it wasn't up for very long, but it's gotten an overhaul. It used to be like orange and kind of weird looking, but I'm really happy with the changes to the dashboard. The notebooks UI, the Aricto folks, they're the ones that have a booth. They've done a whole lot of work on Jupyter Hub. Very happy with those changes. Fairing is something that's under very active development, and that's a way of, from your notebook, not just deploying pipelines, but actually building containers from within your notebook, building, training, and deploying without ever leaving your notebook environment. And then Katib, for running some hyperparameter tuning, a bunch of improvements to that. We've already seen pipelines. That is about all I had. In terms of the roadmap for the next release, that should be out in the next month or so. That's the 0.6 release. And that focuses on multi-user isolation. So that's probably what you're looking for. That's a more consistent story, so not just on a component-by-component basis. We're looking at replacing KSonnet since it's been deprecated. That will be customized. That's a fairly significant effort, so it'll take a while. But we're generally moving towards a 1.0 release, which is a lot more robust for enterprise users, like having smooth upgrades, rolling restarts, that kind of thing, and hardening all of our APIs. So if there's something on here that's missing that you'd like to see, let us know. There are a ton of ways to get in touch, or help us build it. That's always welcome. We're a very open community, really great group. If you want to meet a few of us, we have a bunch of talks. Right after this, we'll be heading over to the Kubeflow BOF. David was just in here. I think he went to prepare for that. David and Jeremy will be David and Yaren. David and Jeremy's talk is tomorrow, and then there are a few other ones as well. So if you want to learn more, check them out. And go ahead and keep the accounts. We'll get rid of them eventually. But if you want to play with that over the next few days, if you want to get a full cluster up and running, it does take a little bit of time, but just give it a little bit of time before adding your auto-provisioning, and you should be able to complete the rest of it. So thanks for being patient. I appreciate that everyone came today.